So this is Dr. Hassan Abdullah with the course Web Applications Programming, and the topic which we are covering is databases, and the topic is 6B. The reason being that when we discuss 6A, I told you that the content which is covered under databases is that requires two videos, so that's why it is divided into 6A and 6B. And the approach of this video and like the previous ones is that it uses the supplemental website, which is easymcq.com/goget, which is a personalized learning management system, and it is way ahead of the traditional approach of having static websites and static slides and which are ancient, which are non-customizable, which are non-interactive, and which are manual, and there are so many limitations, and you cannot track your progress also. So all those features which were lacking in those traditional approach, they are in there in this supplemental website, which is a personalized learning management system. It performs and it allows full text search, advanced and basic, over all the content, over all the courses which are available. If there is a visual disability, you can change the color of the text, the font type, the spacing, you can do many things. And it is optimized for mobile phones, and it is optimized for limited space of the mobile phones. And you can track your progress also, and you can examine yourself, test yourself, identify your weaknesses and work on them. So everything is here for you. So you need to look at these videos which are available at the address in front of you, so as to get the maximum out of this. And of course, you can go to YouTube and type my name, Dr. Hassan Abdullah. It will take you to my official channel, and the videos are available there. They are available on the canvas also. So the approach of imparting education is not like the ancient approach of the slides, which are static, which are non-interactive, and which are non-engaging, and which, so basically it's a question and answer based approach. It challenges you, it is proactive, and it engages you, and it makes you think, and we look at the real life problems, and it is integrated in it. So this is the approach which is being followed, and the topic is of course the database topic, and within that topic there are 12 questions and answers, and each question and answer is a concept, and with each concept there are bullets, then there is a summary, then the bullets are explained and there are references for additional reading, and of course if there is a need there are diagrams also. So in 6A we will cover, we have actually covered the first 5 Q&A, and in 6B we will be covering the remaining Q&As, which includes of course which are listed in front of. And out of these 12 questions and answers, the first 5 have already been covered in the video 6A. And in this video, which is 6B, we will be covering the remaining 6 question and answers, right? So you can see that we will talk about what are primary and foreign keys in a database, because primary key uniquely identify records and foreign keys establish the relationship between different tables. And what is meant by database architecture, how things are connected, how what is the logical picture, and what are the constituents, and what are NoSQL. No means not only SQL. It doesn't say, because there are many databases. For example, for social networks, right? Which we don't follow the relational model, but of course they are databases. So you don't run SQL on them. So not only SQL, so graphical databases, key value databases, and so on. And how a PHP web application connects with a database. So there are one or two ways of doing it, and I'll show you that how that connection is made, how the username and the password and database name are passed, and the connection is made, and why it is important to have or keep regular database backups. And it may not sound very exciting, but it's very important and critical, and how you can do it using a simple approach or using cPanel, which is a hosting panel, which is basically which we will be discussing in this course and using in this course, and how to structure data in a web application for relational databases. Because when we say web applications programming, then the third tier is the database. So how they are, so these are the questions and answer which we will be covering in this video. And so let's move on to the supplemental website. So we read the supplemental website, and move on to web applications programming, which is the course which we are covering. And within this course, we have databases. And within databases, we have already covered the first 5 questions and answers. So we move on to the next one, which is the 6th one. So what are primary and foreign keys in a database? So primary key, basically, if you look at the detail, so basically primary key is a unique identifier which identifies a record in a database. For example, your passport number is a primary key. For example, every vehicle has a registration number which is a primary key. Of course, people can have two cell numbers, cell phones, and those cell phones numbers are unique, but the person is same, right? But the cell phone numbers are not used to identify a person, so that is not really a primary key. But the government issue ID, which is always unique, that is a primary key. So foreign key, what is a foreign key? Foreign key is a key in another table, right? And it can only contain those keys, right, which are the primary keys some in other table. So that is called as the foreign key relationship, or the this will become clear over here. So we have this employee table, and every employee has a unique employee number. Every employee has a unique employee number. And then we have this department table also, right? And they have department numbers also. And of course, a person can be in a department can have multiple people. So I have this person Sam, who's in department 101, and I have this person Adam, who is also in department 101. Of course, they are unique employee numbers. So in the department table, okay, in the department table, I have these department IDs. These department IDs are these are the unique. They are unique, okay. They are unique. But in the employee table, okay, only those department numbers occur which are there in the department table. That is the foreign key relationship. So what is meant by database architecture? All of these things identify a database architecture. Data model, how data is modeled. What is the schema of the database? What database management system is used? Whether it's NoSQL, is MySQL, or it's some other powerful storage architecture. How the data is stored, and how to ensure the integrity and security, and how frequently or infrequently data backup is taken, and is how much it is scalable. So there are many things, okay, and which basically which define, what do they define? They define the database architecture. So database architecture is not something which is very simple, okay, or which is straightforward, because all of this constitutes the database architecture. So data model are the theoretical framework, how data is structured, okay, and manipulated. Schema is a blueprint or a logical design, okay. So this is a logical picture. So logical picture can be anything, right, which suits our purpose, for the sake of understanding also, okay. Then of course, let me clear this first. All right. So database management system, we have MySQL, we have Oracle, and many powerful architecture, storage architecture, how data is physically stored, how it is indexed, what are the devices, and concurrency control, how the queries are running simultaneously, backup and recovery. So all of these things constitute a database. So there are many schemas. There are many database schemas. Some are more popular, some are less popular. Every schema have their own strength and weaknesses. So just to show you that we have this flat file model. It was like an ancient technique, and it's not very powerful, but it's fairly straightforward. And then we have the star schema model. In the star schema model, we have this central fact table here, and we have these dimension tables, and then we have the relational model. So which I showed you before, that we have that employee table and the department table, and we have those relationships, right? So we have this relational model. So there are many schemas there, okay, and there's no There's no good schema or a bad schema. It depends upon the application and depends upon how things have progressed over the last like 3 or 4 decades. The relational model has become very popular. But now we'll be discussing that we have those not only SQL databases also, which are non-relational actually, and they are also they are also equally popular because they have their own application domain. For example, these relational models probably all of the banking system and the finance system are running on those relational models. They're very precise, they're very accurate. But when I am making friends over a social network, or I am sending emails, or I am liking or disliking or whatever, so that's just not very, time is not very critical. It's not going to like have any tremendous effect if my email is delayed by 1 microsecond, or something like this. So we have those not only SQL databases. So stand for not only SQL. Okay. So highlighting that these databases are an alternative, not necessarily a replacement. Okay. So they are there, and of course they don't follow that ACID property. ACID property, we will discuss it. Okay. So ACID, A means atomicity. So either the transaction goes all the way or it does not. Okay. And then of course so so these they don't follow those ACID properties. And there are document stores and key value stores and graph databases for more popular in social network analysis, right? And then we have these document stores, MongoDB. So there are many such databases on which we don't run SQL, right? But they are equally important and they are equally useful for their own application domains. So document stores are NoSQL databases stored in a document-like formats like JSON or BSON, okay, on XML. An example could be like document-oriented database like MongoDB, right? So such as we for different users such as age, so what we different fields like age, preference, purchase history, and so on, stored in a single document, right, instead of having a table, right? So why? Because scenarios where data structure changes frequently or data comes from diverse sources. Because if this is stored in a typical database and there are a lot of changes, then it may end up blocking the entire database and it will tremendously degrade the performance, right? And in a banking environment there may be fewer changes, but on a social network or on a Facebook there might be a lot of this changing taking place. So key value store, simplest form of NoSQL databases, collection of unique keys, right? For example, and these strings can be blobs, basic binary large objects like images and so on for fast retrieval. So these are some of the examples. Redis database and column stores and so on, and then graph databases. So we have the nodes and entities and the edges. So we have the people and we have the people who know people and so on. So these are the examples. So we have this graph database and document databases and so on. And this is the relational model. So they are quite different animals. Okay. So how a PHP web application connects with the database. So I'll show you how this connection takes place and then what are the next steps. So let's look at it. So basically what happens is that you'll start from here. So we have to define a database connection. Okay. So to have a database connection, there has to be a database host. Okay. And to have a database host, you must have a valid username, and you must have the password, and you must have the name of the database. So if you don't have these credentials, then you cannot connect to a database. So what you need to do is that when you have these credentials, you need to make a connection to the database. It could be MySQL connection, or it could be this way also. Okay. And you select the appropriate database, and once the connection is there, you have to actually ensure that the connection is made. And once the connection is made, then you can of course run the SQL commands, and we'll discuss all those commands in the next topic. And of course you have to ensure that the connection is there. Okay. And you then fetch the results and then process those results. Okay. and then you can process them, load them into variables, and perform other operations also. So this is the code here. So we have this. So this is the tag for PHP. So start the PHP. This is the tag where PHP ends, and these are different variables. So you need to put the name of the local host, username, password also, and the name of the database, and then you make the connection. Okay. So these values are plugged in here, and the connection is made, and you check the connection. Okay. So if this returns true, right, then of course you have a connection, or if it doesn't return true, then there's no connection. You give an answer, connection failed. So once the connection is there, then you can do perform all sort of queries. So select asterisk from users. Asterisk means select all the columns from the table name users, and then you load them into this over here. Okay. And then and then you run a while loop, and you read the array values one by one. Okay. And once you're done with it, then you close the connection. So this is how it works. And so this is actually acting as an associate array, and this while loop keeps on loading from the reading from the database, and it keeps on displaying the results, right? So echo, basically it will display echo, and echo is the PHP command, and this will be displayed user, and this username is going to be displayed, and then there's a line break. So there will be rows, and each row there will be a username value from the table users. So this is how it's work. It's fairly straightforward and simple. And then of course you can use it for further downstream application, and then you close. And after you have read all the values, you close the connection. So what is the importance of regular database backups and methods to create them? It is like I cannot say enough how important is regular data backup. Whether your application is a small one or is a medium one or large, it is your responsibility. Of course, your hosting service provider will also be taking the backup, but it's your responsibility to take the backup, and that backup should be basically data loss prevention. Okay, you should not lose your data. It's very valuable, and if disaster happens, then you should be able to recover from that disaster. And if you are unable to recover from the disaster, then how are you going to ensure your business continuity? Your data, your customer data, your transaction is very important, and in certain cases you may be required to take the backup also, and because there are legal requirements also. And there are different ways of performing the backup methods. There's a full backup, there's incremental backup, differential backup, and so on, depending upon the nature and scope and the volume of the backup which is required. And it can be it could be automatic, or you could schedule it, and of course it could be cloud based solutions also. So it is up to you. Full backup copies all the data at once, but it is very time consuming. Incremental backup, only the changes, store it. Differential backup, changes since the last full backup. This is middle ground of full backup and incremental backup, and so on. And of course, these are some of the pros and cons. So data protection prevents data loss during system failures, but it requires storage space, and it requires secure handling, and it requires time also. Business continuity pros, minimizes downtime, ensures continuity of operations, but the cons are may involve costs for automation or backup services. Compliance helps meet regulatory and audit requirements, must be configured to meet specific standards. It's just not that you take a backup as per your liking or dislike. All right, so we are towards the end. How database backup can be taken using cPanel. So you log into the cPanel, and there is the option of backup, or there is a backup wizard also. And then you select the download MySQL database or backup, which will be a text file with insert commands. And then you chose to take the backup, and then you can also restore it also. And when you store it and you run it, that update command is executed. So you log into the cPanel, and this is the address where you will find it to log in, and you go to backup or the backup wizard. So the backup basically is user friendly. Backup is better. Okay, simplifies the process, right? And you can download MySQL database backup, download on your machine and keep it safe somewhere. Don't leave it in the cloud. And then you decide about what you need to backup, and then you secure it. Okay. So these are the options. You have the backup, you have the full backup, you have the accounts backup, partial backup, and so on. So you can work with them in your cPanel account. And even if you get a free cPanel account, more or less you will get this type of structure. So how to structure the data in a web application for relational databases? So identify the entities and attributes. So this is the whole, as a matter of fact, this can be a whole lecture on it. So entities are basically whatever is important in your domain, in the way in which you're working. For example, in the context of a university, student is an entity, teacher is an entity, course is an entity, while course is not a physical entity. And then of course we have the attributes. So attributes are the properties. So a course has a name, a course has a code, a course has the credits, and so on. Define relationship between entities. So a student is registered in a course, so that's the relationship. Use primary and foreign keys that we have discussed. Normalize the data. Normalize the data, you remove the redundancies and you remove the duplications and so on. And because that will help provide good performance. And then you design the tables with appropriate data types. So better if it's date, you use a date type instead of a string or something else. And apply the constraints and indexes. Indexes give performance. And plan for scalability and performance. So the details are here. So you can read all those details, and this is just a snapshot of the structure of a certain application. And as you can see that we have this serial number, which is an integer, which is a primary key, is auto increment. So whenever a new record is added, so this is incremented. And then this is the st name, and there is the email. So these are the attributes. And then there's the sys date and sys time also. So the type is date, the type is time here. And then more or less things are simple. So this is ANS, probably its answer. So the answer choice is one character, A, B, C, D. And then this is the question body, and the question choice A, B, and so on. And so the list goes on. So you see, this is how you structure it. So you need to take into consideration everything. Okay, it's not that you start developing things and then you keep on adding things to it. This is just a recipe for disaster. So that is all for the video lecture 6B. Thank you very much.